Hey guys, we are going to continue our exponential and logarithmic functions. So the last time we talked about exponentials and what they were and what their graphs were and just how the transformations moved it around. Today we're going to start logarithms. So we will graph them, but before I start making you graph them, I want you to know what it is and how we're going to use it in Algebra 2. Okay, so got some fill in the blank and some vocab for you. So what is a logarithm? All right, a logarithm, which we say log for short, it's the exponent to which a specific base is raised to obtain a given value. All right, these are the inverses of exponential functions. Okay, so every log has a base, just like all of my exponentials the other day had a base. So we had a base of 2 raised to a value of x. We had a base of 1/4 raised to the power of x. Okay, so that 2 and that 1/4, that's a base. A log with a base of 10 is called a common log. So this is something that is the most commonly used. If no base is written in for my log, then we're going to assume that the base is going to be 10. So like if I give you something that looks like this, just log 5, that's like saying log base 10 of 5. Okay. What we're going to first do today is, since logs and exponentials are inverses of each other, we can rewrite them back and forth between the two forms. So if I have an exponential function where I have a base raised to an exponent that I don't know, and it's equal to a value, I can rewrite it to solve for that exponent, because right now I don't have a way of doing that. Okay, if I had x squared equals 25, you could solve for the base, right? You're like, oh, well, the base has to be 5 or it has to be -5, okay? But instead, if I gave you something that looks like 3 to the power of x equals 12, what exponent could I put there, right? I know 3 squared is 9. I know 3 to the power of 3 is 27. But what exponent could I use to get 12? Okay, so that's where logarithms comes. We use logarithms to solve for the missing exponents. Okay, which we can't do up until now. So in order to do that, since we are used to seeing exponentials, we can rewrite the two back and forth between each other. So if I am given an exponential, like 9 squared equals 81, that's an exponential form. I can convert it to a log if I use the L. Okay, so you'll notice here, logs always start with the word log. That shows it's a logarithm. See how my base comes first? My base is on the bottom. Then I have my value of a, and it's equal to our exponent. Remember, because we use logs to solve for exponents. To draw my L, to remember the order, I jump down to my base of 9 equals base of 9 of 81 equals our exponent of 2. So you can use the L to rewrite it into log form. Okay? I can also do that to go the other way. So if I'm given a log and you are asked to rewrite it in exponential form, if you want exponential, so I want the base, I want the exponent, I want it equal to a value, we can use an E to put it in that form. Start with my base of 8. Draw my E. My exponent is 3, and it's going to equal 512. Exponent of 3 equals 512. Okay. So when you have all numbers like that, it kind of makes sense. I'm not going to say 8 to the power of 512 equals 3. That doesn't make sense. Okay. So my last two numbers get switched. Your base is always first. Your base is always first. Your base is always first. All right. And then the exponent and the value get switched, depending on if it's a logarithm or an exponent, right? So I want you to pause the video. I want you to practice just the rewriting back and forth. You're going to fill in this table at the bottom. I want you to, I guess we can do this one together, and then I'll make you do these on your own. Let's do this first one together. So here we go. The top is going to be the exponential. The bottom is going to be the equivalent in log form. So my first one's already done for me. 3 cubed equals 27. It's the same thing as log with a base of 3 of the value of 27 equals the exponent of 3. All right, so here I have 5 to the -1 power equals 0.2. It wants me to write it as a logarithm. So I'm going to use my L. So I'm going to have a log with a base of 5 of a value of 0.2 is equal to my exponent of -1. Logs always equal exponents, okay? Every single time. My next piece, I already have a log. It wants me to rewrite it in exponential form. My base is 4. We're going to draw my e. My exponent is 2, and we're going to be equal to 16. Makes sense. If I add 4 to the 16th power equals 2, I should notice something's wrong. 4 squared equals 16. All right, and then we have one more. We have 8 to the power of 0 equals 1. We're going to write it as a logarithm, so we always have the word log first to show it's a logarithm. My base is 8. My base always comes first. The value we're equal to is 1, and logs always equal the exponent, which is 0. Draw my L. I get to go in that same order. Okay? So now I want you to pause, and I want you to work on these last two charts. So here, these are all exponentials. I want you to write the log form. Over here, these are all logs. I want you to write them in exponential form. All right, so pause and try it. All right, check your answers with mine. So in my first table, we have log written first, and then the base still comes right afterwards. So I have a log with the base of 3 of the value 243 equals the exponent of 5. So again, every single piece of my first table should be equal to the exponent. Then we have log of 25 of the value of 5 is equal to 1/2. My third one had a base of 10, so technically I didn't have to write it. That's where my common log comes into play. The reason why we talk about common log is because if you have a graphing calculator, okay, you might notice there is a log button. Where is it? It's right here next to your 7. You can only push this button if you have a base of 10. Okay, so if you don't have a base of 10, which everything else in here is not a base of 10, you can't use your calculator. Okay, there is a way to use it. We're just not there yet. Right now, though, you can't use that button unless it's a base of 10. All right, looking over at my logs, so as I changed it over to exponentials, my bases were still first. So the 9, the 2, the 8, the 4, the b, those small numbers are my bases. Logs are equal to exponents. So now my exponents are 1, 9, 1/3, -2, 0. And we're equal to the values of 9, 5, 12, 2, 1/16, and 1. All right, which makes sense. My last one, because isn't anything raised to the power of 0, 1? Makes sense, right? That property is going to come up again later, so don't forget it. All right. All right, so here we go. So a logarithm is an exponent. So my rules for exponents are going to also apply to logarithms. We're going to stick with these two today. We're going to do more properties after this video. There's a whole lot more. But we're going to stick with this one right now. So here, some special cases, some special properties. If my base and my value are the same number, that means the exponent had to be 1, right? Because if I rewrite it, that means my base raised to the power of 1 equals the same number as my base. That makes sense. Anything to the power of 1 is itself, okay? So some examples, there's one here, but I can give you another one. Let's do 4, okay? If I have log base of 4 of 4, that has to equal to 1. So when your base and your value are the same number, that means the exponent had to be a 1. Okay? And again, I could rewrite this as saying 4 to the power of 1 is 4. That's why that makes sense. If our logarithm is equal to 0, that means the value had to be 1, because no matter what my base is, okay, if my value is 1, that means the exponent had to be 0. Anything raised to a power of 0 is equal to a value of 1. Okay? It does not matter what it is. If I have a log with a base of 37, but the value is 1, I know that has to be equal to 0. Okay? Because if I rewrote that, that would be 37 to the power of 0 equals 1. Okay? So those are some 2 special cases on how to get a 1 from our logs, okay, or 0. This change of base formula down here is something you should write, especially if you have a calculator, graphing or not, because even scientific calculators have that log button on there, okay? So when it asks you to evaluate logarithms, you can use the log button. We separate the log. We do log of my value divided by log of my base, okay? And then it's going to tell you what the exponent is equal to. So just to give you an example of something we already know the answer to, if I have move that. If I have log with a base of 8 of 64, and I'm like, what was the exponent? Well, we know 8 squared was 64, right? We know the answer is 2. But if I don't know, because there's numbers that we're not used to, okay, to use the calculator, what we're going to do is we're going to do log. The parentheses open up automatically. We're going to do 64. Close your parentheses, then divide log. Parentheses will open up again. We're going to say 8, and we're going to close it. And I'm going to show you how it does give us 2. Okay? So again, my log button is next to my 7, so we're going to push log. See how it pops up? Opens parentheses. We're going to put 64 and close it. Then we're going to divide and do log of 8. And then when I push enter, it's going to give me the exponent, which is 2. Okay, so that's a way we can evaluate logarithms using our calculators as long as all the numbers are there. If you have a TI-84, okay, if you don't have a TI-84, ignore me for a second. If you do, I want you to push this math button over here that's underneath your alpha. Push math, okay? And then on this math menu, I want you to push your down arrow all the way down. Oops. At the very bottom, you probably have something that says log base. Okay, I want you to go to that and push enter. And now you can change the base of 10. Okay, so I can now change this to have a base of 8 and a value of 64. And now I can find my missing exponent, which is going to be 2. Okay, not all calculators have that second feature. You can use the first feature with any calculator. Okay, only the higher level graphing calculators have that change of base option in them. All right, so just keep that in mind. All right, so that is your introduction to logarithms, how to rewrite them, how to evaluate them. Go ahead and go to the next video, and that is going to show you how to solve and simplify using properties of logarithms. There's a whole lot more, just like all the laws of exponents, adding, subtracting, multiply, divide, negatives, those all also apply to logarithms, okay? So go ahead and turn this one off and go to the next one.